So for this next section, we're going to have a look at the water chapter, chapter 19. And we're going to start with looking at hard water and what hard water is. And a lot of you will have hard water in your houses, but there's different types of hard water. So the basic idea that hard water is water that does not easily form a lather when you mix with soap. So basically, when you put a small bit of soap in your hands and you go to wash your hands, if you're not getting lots of lather and lots of bubbles, then that's probably hard water you're dealing with. If you're washing your hands in soft water, you're going to get lots of lather and lots of bubbles. Now, this is a definition that you need to know and is constantly asked on the Leaving Cert, so that's something to remember. Now, when we actually look at hard water, there's actually two different types of hard water. So the first one that we're going to look at in terms of hard water is something that's called temporary hardness. So temporary hardness, as the name suggests, can actually be removed, and we're going to have a look at that. The other type of hard water is permanent hardness. Now, permanent hardness, despite the name, isn't actually always permanent. Permanent hardness for hard water can actually be removed, but it can't be removed by the same way we remove temporary hardness. So what we're going to do is have a quick look at temporary hardness and see what the difference is. Well, with temporary hardness, this is hardness that can be removed very simply by boiling. So if we boil the water, temporary hardness will be gone. The permanent hardness then is the opposite, which it can't be removed. Can't be removed by boiling. Now, there's other ways of getting rid of permanent hardness. We're going to look at those in a couple of minutes. So let's have a look at temporary hardness. It can be removed by boiling. And we're going to have a look at, well, first of all, what causes it. So when we're looking at hard water, what actually causes it? So in general, the cause of hard water is going to be either calcium ions, Ca2+, or magnesium ions. They're the main causes. And there's a couple of things that we need to look at with those for temporary hardness. So if we look at, say, this first diagram here on acid rain formation, if we take the basic idea of rain falling from the sky, so if you have general rain just falling down and it's falling onto our rocks and our landscape and all that sort of stuff, rain water by itself is actually not a problem. Rainwater will fall on our landscape. And in our landscape, we have lots of limestone. Now, limestone is not soluble in water. In other words, the limestone will not dissolve once rainwater hits it or pure water hits it. The problem is the rain that's coming down is not pure. It's not pure water. And the main reason for that is because we have vehicles, we have factories, we've got industry, and they produce large amounts of carbon dioxide. They also produce sulfur dioxide and nitrous oxide too. And as those fumes go up into the air, they're evaporated, they mix with the water, and the water forms acid rain. So when the rain falls, it's not actually pure. And because the rain is not pure, what happens is the limestone starts to dissolve. And as the limestone starts to dissolve, you end up with pieces of lime inside in the water supply. That water supply then runs off the mountains and it goes into the lakes and the rivers, which ends up in our water supply. So it's because the rain that's falling has been polluted by all the other things. That's why we end up with lime in our water. Now, this can be removed by boiling. Let's have a look at that. So the first thing we're going to actually do is have a look at some of the equations involved in this. So in this particular picture here, you can see the hard water inside what is caused inside the pipe. So a house with hard water, your pipes are often like this, and it leaves a deposit on the inside of the pipe. If you have soft water, you're going to have no deposits on the inside of the pipe. Because of this hard water, machines like washing machines and dishwashers, the motor has to pump harder to get the same amount of water through. So here you're getting a certain amount of volume through. Over here, the machine has to work harder. Because the machine works harder and the motor works harder, then things like washing machines and dishwashers actually don't last as long because they're working harder. Let's have a look at the equations for this, the chemical equations behind this. So the first thing we're going to actually look at is, well, when the rainwater reacts with the carbon dioxide. So the carbon dioxide coming off pollution reacts with water. Now carbon dioxide and water forms a thing called carbonic acid, H2CO3. Now this carbonic acid is the same acid that you would find in fizzy drinks. This is the same stuff that rots away your teeth if you're drinking too much fizzy drinks. So that's carbonic acid. Now this is what's falling. But how does the temporary hardness arrive? Well, the limestone is insoluble in water, as we've said already, but it does react with the carbonic acid. And an acidic solution of carbonic acid will then react with limestone, which we find in the soil, especially in Ireland, and then it forms a thing called calcium hydrogen carbonate. So if we actually look at this in equation format, so we have calcium carbonate, which is CaCO3. So this is basically limestone. This is what's in the ground. The limestone then reacts with the carbonic acid, which is falling in the form of rain. So this is your carbonic acid. And that forms a substance called calcium hydrogen carbonate, which is Ca, and it's a HCO3 twice because this is a single ion. So this here is calcium hydrogen carbonate. Now, the calcium hydrogen carbonate is soluble. So this is soluble in water. It will dissolve down. Whereas your limestone, generally as a rule, is not soluble. So without this carbonic acid, we wouldn't have any lime in the water. So basically, this is what's causing your temporary hardness. The Ca2 plus ions, because this here splits up into Ca2 plus when it dissolves in the water, and your hydrogen carbonate ions, so HCO3. So it's this Ca2 plus that's causing the temporary hardness. These things here, which is the HCO3, these have nothing to do, or they've no effect on hardness. But the Ca2 plus is what causes the hardness. So then back to the original question is, how does boiling remove it? So what effect has boiling got on this? Well, it's basically the reverse of this equation. So what we now have is, if we have hard water, we have calcium hydrogen carbonate, CaHCO3 twice. So this basically is just calcium 2 plus ions in water. And when you boil it, it causes a reaction to happen. And what happens is they rebond and you end up forming calcium carbonate, which is a precipitate. So in other words, the calcium ions come out of the water and are precipitated as calcium carbonate. Now, again, this thing here is insoluble. In other words, it comes out of solution. And you also form carbon dioxide and water. So you don't form carbonic acid per se. So the two equations are the reverse of it. The boiling just reverses the equation. This removes the Ca2 plus. So Ca2 plus is now removed. So therefore you've got soft water. So the effects of this will be, if you have a look at these photographs here, you can see the taps here covered in lime scale. And most people probably have a kettle like this at home, where you look into the bottom of the kettle and you can see little pieces almost burnt onto the bottom of the kettle. So again, this is all lime scale. So obviously, how is it not being removed out of the kettle if the kettle is being boiled? Well, the deposits are actually sticking to the bottom of the kettle. So one of the ways you can actually get rid of this is adding a little bit of acid. So if you get a lime scale remover from a supermarket or something like that, you're basically talking about having CaCO3 and you're going to react it with acid. Most of those will contain something like hydrochloric acid, and they'll end up producing calcium chloride and water and carbon dioxide. Now I haven't balanced that equation there, but that's basically what will happen. So carbon dioxide will be given off, and there's carbonate ions as well. Another thing that you could do here is you could add vinegar. So again, vinegar is an acid. So if you add an acid to a base, it will neutralize it. So vinegar is something else you can add to the bottom of these just to remove it. So that's it for temporary hardness, which can be removed by boiling. And now what we're going to have a look at is permanent hardness. So permanent hardness can't be removed by boiling. So your temporary hardness, again, caused by calcium ions, and there's some magnesium ions possibly as well. But permanent hardness then is often caused by other chemicals. So again, they're calcium containing, but this time they're actually sulfates. So calcium sulfate will be one of the main ones that will cause it. And also because of magnesium is often in the water as well, you would get magnesium sulfate can also cause permanent hardness. Now, how do we get rid of these? So again, as we stated already, can't be removed by boiling, so there's got to be other ways of doing it. So the first way of doing it is by distillation. So we've done distillation before, where you separate water from something else. So this is number one, distillation. So basically what will happen in here is you end up taking the water, which contains the calcium sulfate and the magnesium sulfate. So this is your water. Let's say we've got calcium sulfate. And what it does is it boils the water. The water travels up through the tube and into the Liebig condenser, and it goes down through the Liebig condenser. And what happens is the water ends up at the bottom here. And this water will be pure water, and your calcium sulfate will be left as a deposit at the bottom. So that's your basic distillation, separating the water from the calcium sulfate. The problem is distillation is too awkward to do on a mass scale. You can't be doing this in lots of situations. There are other ways of softening the water, and this is the second one. We can use washing soda. So washing soda is a common item. It's found in the likes of Radox bath salts. So you can see the bath salts there, and also bath bombs. All of these, when they're put into the water, will soften the water. And when the water is softened, it removes them. The third way you can do it is via an ion exchange resin. And an ion exchange resin takes the calcium and the magnesium out and replaces it with hydrogen and hydroxyl ions, which give you water. We'll look at that in more detail. You may have an ion exchange resin if you've got hard water in the area where you are. You may have an ion exchange resin similar to this one here. In your garage, you may have tanks like that, or ones that are a little bit smaller. You may have them under the sink either. And then those of you who don't have any of those, you probably have one of these in your fridge, which is a Brita water jug filter. And you can see that filter there has to be changed on a regular basis. And that is an ion exchange resin that takes out the calcium and the magnesium out of the water and replaces it with hydroxyl ions and H pluses, which of course gives us water, pure water. So that's an ion exchange resin. We'll come back to this in part 2.